Hello dear student, how are you? I hope all of you will be fine. My name is Piyush Sharma and in this video lecture we are discussing new chapter of class 10th electricity. We know that fan, toaster, all are known as electric appliances, and these electric appliances is working due to electricity. Electricity is a kind of energy. Like if we take an example of our body in a daily life, everything which we are performing, writing, playing, anything, this can be possible due to the energy which we get from our food. Likewise, all these electric appliances get energy from electricity. Now, electricity is a particular concept. So, what is behind the electricity? Definitely, one basic building block which is known as electric charge. Now, as we know, the basic building block behind the electricity is electric charge. So, here we start our lesson from electric charge. Electric charge, the source of all electricity is charge. As a charge is the basis of electricity, we often need to know amount of charge on the body. As you know, matter is made of protons, electrons and neutrons. So inside the particular atom, nucleus which is positively charged, and outside the nucleus there is a electron which is a negatively charged. Now the SI unit of charge is Coulomb by the name of scientist. Each proton carries a charge of 1.6 into 10 raised to the power minus 19 Coulomb, and each electron carries an equal negative charge which is minus 1.6 10 raised to power minus 19 Coulomb. Now, definitely, ये electric charge आता कहाँ से है? Now in the primary classes, we knew about a particular game. हमने गेम खेला है नए नए स्केल से. जैसे ही हम अपने हेयर से रब करते थे और कुछ रबर के पीसेस हमारे पास हुआ करते थे, तो हम देखते थे सी द मैजिक. नाउ ऑटोमेटिकली द रबर पीसेस अट्रैक्टेड बाय द स्केल आफ्टर रबिंग. सो वी नो दैट ऑल मैटर इज मेड बाय electron, proton and neutron. So that's the reason when we rub or by friction, the charge is transferred from one body to another body. Okay, now we are going to brief about electric charge कि electric charge होता कहाँ से है और किसी बॉडी पर किस टाइप से और स्पेशली ये किस तरह से वर्क करता है इलेक्ट्रिसिटी. व्हेन वी टॉक अबाउट मेटल्स, so metals generally are good conductor of electricity. Why? Because they have a good amount of free electrons. These free electrons are charge. Now look at here. In the particular atom, there is a nucleus where is a proton and neutron live together, known as nucleons. The proton and neutron together known as nucleons. Just outside the nucleus there is a different orbit, and the different orbit there is a different electrons are there. Now what happened? होता क्या है? जैसे ही when we go inside the atom, just outside the nucleus electrons are there. So nucleus are positively charged and all the electrons are negatively charged. So now what happened? The nearby electron जो first orbit में होगा उसका attraction nucleus के साथ strong रहता है. Like in a class, front bench पे जो बच्चे होते हैं उनका concentration even ज़्यादा होता है as compare of last one. Sorry, last benchers. But जैसे जैसे when we are going means gradually when we just going to the higher order of orbit, so what happened? The attraction due to the nucleus gradually going to decrease. Now what happened due to this, ये जो लास्ट वाले इलेक्ट्रॉन्स होते हैं उनका अट्रैक्शन कम होने लगता है और धीरे धीरे अगर बाई चांस हमको इस पर एक्सटर्नल फोर्स लगाते हैं, व्हेन वी आर अप्लाइंग एक्सटर्नल फोर्स, सो व्हाट हैपन, दे लीव द ऑर्बिट एंड बिकम फ्री. नाउ the number of free electrons are higher in metals. That's the reason metals are good conductor of electricity. Okay, especially silver, best one. Why? Because the number of free electrons are higher, and here the flow of charged particles definitely known as electricity. So this is the apple pie order about the electricity. Now next we are going to discuss about electric current or electricity. Electric current, like water in a river, blood in our body. A particular thing which is in steady state means continuously flow, known as current. In the river and water case, it is called water current, and blood, it is known as blood current when it is flowing continuously. Likewise, when electrons are continuously passing inside metal or electric conductor, constitutes electric current. So here the flow of charged particle is called an electric current. The current passing per unit time through a given place is the magnitude. Do you know the magnitude? Magnitude means numerical value of the electric current that at that place. Thus we can write, suppose this is a particular metal piece, okay, and inside it q number of charge is going to pass in time t. So here we can write about electric current I will be equals to q by t, where q is charge and t is time. So in that particular place we can say the electric current will be equals to I equals to q by t. Now because the SI unit, you also know what do you mean by SI unit, a particular system who decide which particular unit assigned for a which particular physical quantity. Again, what do you mean by physical quantity? Those quantity which we can measure easily known as physical quantity. So here electric current, okay, and in a class 9th, mass, weight, time, all are known as physical quantity. So again we come back to here. So the particular SI unit assigned for the electric charge is coulomb and the time is second. So here the SI unit of electric current by the new scientists known as ampere. So the ratio of, that means the ratio of coulomb per second, also known as ampere. Now here we are talking about the definition of 1 ampere. If 1 coulomb of charge passing through a place means a particular metal piece, in 1 second the current there is 1 ampere. Again, if in a one particular certain place only 1 coulomb of charge is passing over a time 1 second, so here we can set that in that particular place the electric current will be 1 ampere. Now in the next part of this video lecture we are discussing about very important concept, electric circuit. Next topic is electric circuit, a particular path, like vehicles, car are moving on the road, not in a home, okay, like charges is moving in a one particular direction, and the particular path here known as electric circuit. A closed path in which a current can flow is called an electric circuit. An electric circuit may have one or more electric elements like bulb, cells, switch, metal wires, etc. and each element of a circuit has a specific function to play, like wire, electric wire. You can also see in your home. Wire can be used to connect to the next thing. First connect to the bulb, then bulb connect to the particular switch. Like switch can be used to either complete or break the closed path. When the switch is open, so electricity cannot flow in the circuit. When circuit is closed, so electricity is going to pass in the circuit. So here I am drawing one particular systematical diagram of electric circuit. Look at here, this is the source, the cell, and here I am joining one particular electric bulb, okay, and here it is a one particular device known as a meter, and here it is a switch. So here the continuous and the closed path, you can see continuous and the closed path is known as systematical diagram of electric circuit. And here in the parallel one more device which is known as voltmeter. The particular device, a meter, which is measure electric current, and it is placed in a series combination. And why we use a series combination and what is the meaning of series, we will discuss in the next videos. Now voltmeter, a particular device which can measure potential difference. Now what is the potential difference? Now we will discuss in my next video lecture, and it is always placed in a parallel combination. So I hope you enjoy this video. Maybe in the starting of the chapter you also have some problems, you queries, so please feel free to ask to me. So thank you for watching the video, but wait. So whatever the topic, please make a habit, whatever the topic you finish or going to finish, then after the particular topic, please make a habit to perform a numerical, a rated numerical. I am also going to solve a particular numerical. Problem solving session, we discuss one numerical. Calculate the number of electrons constituting 1 coulomb of charge. So in this particular type of numerical, we should know about the amount of charge, and the amount of charge we can easily calculate by the formula Q equals to an E, where Q is a charge and N is a number and E is a charge on electron. So here in this question already given that the amount of charge is 1 coulomb. So Q already given 1 coulomb, and the calculate the number of electrons. So we have to know about N is a number, and we know the charge on the electron is minus 1.6 into 10 raised to the power minus 19 coulomb. Now we have to find the N number. So look at here, we have to place the value here. Q equals to Ne 1 coulomb and minus 1.6 into 10 raised to the power minus 19 coulomb. Here this one is cancelled. Now N, because we are calculating number, so not required the negative sign, we can omit also. So here we can see N will be equals to 1 upon 1.6 into 10 raised to the power minus 19, and here we can also write like that. So this will be 5 and 8. Now we going to divide. It will be 0, then 6, then 2, and then finally 5. So the numerical value N will be equals to 0.625 into, by the law of exponent, it will be 10 raised to the power 19, or we can shift the order of magnitude. So it will be 6.25 into 10 raised to the power 18 electrons. So here 6.25 10 raised to the power 18 electrons constitute 1 coulomb of charge. I hope you already enjoyed the video. Thank you so much.